In this video, what I want to do is show you exactly what you need to know to evaluate trigonometric functions using the unit circle. Then what I'll do is I'll go through my 5-step problem, so therefore you can follow step by step how to evaluate any trigonometric function using the unit circle. And then what we'll do is we'll go through a couple different examples, so therefore you can see how I'm using the knowledge that I'm about to share with you in this video, as well as my 4-step formula to be able to evaluate your trigonometric functions using the unit circle. All right, so let's go ahead and get started. Now, the first thing that I think all students need to understand when you are trying to evaluate on the unit circle is at least the first quadrant. Now, I know a lot of times when I introduce the unit circle to my students, they look at all the points, they look at all the angles, and they just get overwhelmed. They're like, oh my God, there's no way I'm going to memorize all that stuff. Like, that's just way too much information, right? It's like an information overload. So the good news is I don't want you to memorize all of the points on the unit circle. I truly believe if you can memorize these first quadrant, then you know everything you need to know as far as to evaluate using the unit circle. Now, again, don't be mad at my nice little quarter circle, okay? I know it's not going to be perfect here, but I want you to understand here that the unit circle here, right? I'm just going to do a nice little horrible representation here, can be represented on the XY axis, okay? So we have our X-axis, we have our Y-axis, and what we're going to do though is only focus on the points in the first quadrant. So remember, the unit circle is called the unit circle because we have a radius of 1. So this point right here, we can represent as 1, 0. This point on the unit circle, we can represent here as 0, 1. Now, there's going to be 3 main angles that we're going to be able to use from the unit circle. And again, if you're interested on where these points come from, these are going to come from your special right triangles. All right, that's why we're using this 30, 60, 90, as well as 45 degrees. So basically what we have is just special right triangles with a hypotenuse of 1 kind of placed on the unit circle and shaped, and that's where we're getting these values. So I have a lot of great videos on explaining the creation of these points. But for this video, I just want to keep things fairly simple. And you can also just without having to use the unit circle, you can also just kind of memorize where these points are, right? There's the hand trick, to kind of remember. I think one of the easier ones is just understanding, just put 2 under all your denominators, right? And then you just have square root of 1, square root of 2, square root of 3, right? Square root of 1, square root of 2, square root of 3. So you can quickly go ahead and recreate the point on the unit circle pretty easily, right? And it just takes a little bit of practice, a little bit of experience, doing this a couple times, maybe on a test or in your homework, and voila, there you go. Now, one thing that students a lot of times do forget is what these angles are. So I always like to memorize them at first with students with using degrees. So you can say that's, 30 degrees. Then this one is going to be 45 degrees. This one is going to be 60 degrees. And this one's going to be a 90 degrees, right? So we're kind of going in this ascending form. It kind of gets easy. But sometimes with radians, it gets tricky because we're actually it looks like, even though we're still going in ascending as far as angles, the denominator is getting bigger. So sometimes it just gets, or the denominator is getting smaller. So sometimes students think that it's descending, but it's not. So this angle in terms of radians is going to be a pi over 6. This angle in terms of radians is going to be a pi over 4. This angle in terms of radians is going to be a pi over 3. And this angle in terms of radians is going to be a pi halves, okay? So again, these are going to be the points that I want you to understand, that you absolutely need to understand. I don't believe that you need to memorize the whole unit circle. I truly believe if you can understand this information and basically have this ingrained and be like, I know those angles and I know those points, then you are going to be all set. But you need to know that first. That's why I wrote that in first, all right? Now, the next thing you need to understand for evaluating on the unit circle is the functions, right? You need to understand when I say the sine of an angle, what are you looking for? So we need to understand our 6 trigonometric functions. And our 6 trigonometric functions we have is a sine of theta, cosine of theta, tangent of theta. Then we have the reciprocal functions, which is going to be the cosecant of theta, the secant of theta, and the cotangent of theta. Now, theta is just representing our angle, right? That can represent any one of those angles here, even anything on the second, third, other places on the unit circle. Now, when we have a point that is on the unit circle, we can simplify our definition of our trigonometric functions. A lot of times students remember the trigonometric functions from triangles, right? Sine is opposite over hypotenuse. Tangent is opposite over adjacent, which is correct. And remember, guys, these points come from actually triangles on the unit circle. So it's not like we're getting away from that definition, but what we're doing is we're simplifying the definition based on points of the unit circle. And because the hypotenuse is 1, the sign of your function is going to just represent the y coordinate, right? It's technically opposite over hypotenuse, right? And let me just do a quick little example here. It's technically y coordinate opposite over the hypotenuse is 1, but y over 1 is just y, right? So that's why that's a quick little example you can see why it's just going to be the value of y, why it's not, why we're not using opposite over hypotenuse, but you can still do that. It's just y over 1. Cosine is going to represent the x coordinate, and tangent is going to represent y over x. And again, I will preface this one more time. This is only going to be true, these x and y coordinates, when we're dealing with our points that are on the unit circle, all right? The cosecant is the reciprocal of sine, so therefore that's going to be 1 over y. Secant is going to be 1 over x, and the cotangent is going to be a x over y. All right, so when I give you a trigonometric function and an angle, this is what we're looking for. We're looking for that point on the unit circle. Now, again, I only gave you the points in the first quadrant. So what are we going to do about all these? Well, to understand, you don't need to know all of those, but what you do need to understand is what we call the reference angle. All right. Now, when we first learned the reference angle, a lot of students are like, why do we need to know the reference angle? Well, the reference angle is basically going to be your best friend. It's going to make your life so much easier, because if you don't use the reference angle, then what you will need to do is understand, or you'll need to know all those points. And I don't want you to be doing that, okay? So what we're going to do is I'm just going to kind of draw 4 different examples of some graphs that you might see, or some angles that you could have on the unit circle. All right. And then what we're going to do is we're going to talk about the reference angle. So to give you a quick definition of the reference angle is the acute positive angle between the terminal side of a terminal side and the x-axis. So let's have our terminal side in standard form is always going to be the positive direction of the x-axis. Then we're going to have our terminal side, which is going to be like our rotation. So let's go for our angle here. All right. So here's an angle, and this is going to be our angle theta. Okay. Here is an angle in the second quadrant. Here is an angle in the third quadrant, right? And you can all agree with me okay, yep, these are all angles. And here is an angle in the fourth quadrant. Okay, so those are all angles in standard form, and we all call them theta. Now we're dealing with the reference angle. I said the acute positive angle between the terminal side and the x-axis. So I don't want you to go over here. That's not acute, right? That's obtuse. So that's not going to be the reference angle. The reference angle is going to be between the terminal side and the x-axis, and we're going to denote it by using theta prime. So over here, my reference angle is between here and here, theta prime. Here, it's going to be theta prime. And then over here, it's going to be this little sliver right here. So again, we're just looking for this kind of gap, right? How far is our angle away from the x-axis? Now, notice when I was drawing theta, I did an arrow, right? Because I'm representing direction. I didn't do it for the other two. So oops, I might as well make sure I do that. But I'm showing direction, and that's very, very important. But when I'm talking about my reference angle, I'm not talking about direction. I'm just talking about the distance. I just want to know how far is my terminal side to my x-axis, and that's it. Okay, so it's very important to understand those reference angles. By knowing the reference angle, we can now evaluate for any point or any angle that's going to be on, the unit circle. But that's not going to be good enough. The signs of the quadrants. All right. So, and the reason why this is important is because when you want to evaluate on the unit circle, we can't just use the first quadrant, right? The first quadrant we are going to be using, right? But notice how these are all positive. And if you look in the other quadrants, you're going to have different signs. So let's kind of go through a review of the quadrants. So here, any point that's in the first quadrant is XY, right? And that is your first quadrant. We like the first quadrant. And that's why I picked it out of all the other quadrants, because everything's positive. That makes life easier. In the second quadrant, we have a negative X, positive Y, right? So that is going to be our second quadrant. Notice how X is now negative. The third quadrant, I'm going to have a negative X, negative Y. And then in the fourth quadrant, I'm now going to have a positive X and a negative Y. Okay, so you need to know the signs. You need to know reference angles. You need to know your functions. And you need to know the first quadrant. So what is this 4-step method what is the 4-step method that I can use to evaluate any trigonometric function using the unit circle? So let's go to that is my, I think 4-step, 5-step method. Yeah, no, actually, I'm sorry. It's the 5 step method to evaluate. Okay, let's go ahead and take a look. So the first method that I want, or the first thing that I want you to do, and again, we're going to do some practice problems. So I'm going to go through this step by step, and then what we'll do is I'm actually going to put this into practice. So it might, if it doesn't make a little bit of sense, hold on, stay with me, and we'll actually do some examples. So step number one is I want you to sketch the angle. Okay, so when you're given a trigonometric function, right, of an angle, like, sine of, 7 pi, I want you to sketch the angle. Now, sometimes you can sketch the angle in your head. Sometimes you need to draw it. But anyways, sketch the angle that you are given. Okay. Step number two, once you've sketched the angle, you need to find the reference angle. So find the reference angle. And again, remember, the reference angle is the distance from the terminal side to the x-axis. The reason why we want to find the reference angle is because we want to match the reference angle to our point in the units in the first quadrant. So again, if we can evaluate our trigonometric function on the first, if we can evaluate our trigonometric function on the unit circle, then our reference angle is going to be one of these 3 points. It's either going to be pi over 3, pi over 4, or pi over 6, right? Because it has to be acute, right? It can't be any larger than that. So our three reference angles is going to be one of these 3. It can't be pi 0 or pi half because those would not be acute. So it's literally going to be one of these 3 answers. It's going to be one of these 3 angles. That's it. Okay. So you got like 3 options. And I think that just makes your life a lot easier. So once you find the reference angle, then the next thing what you want to do is find the point in the first quadrant. So find the point in the first quadrant in Q1, right? So again, let's say a reference angle is pi over 3. Okay, well, if the reference angle is pi over 3, then boom, here's my point, 1/2 comma square root of 3 over 2. If the reference angle is pi over 6, my point is square root of 3 over 2 comma 1/2. Like, done. You got it there. All right. Then the next step is to figure out this, find the quadrant and label the sign. And I'm not sure label the sign, but let's just maybe say identify quadrant. And what I mean by identify the quadrant is we want to know, right, when we're dealing with like what is going to be positive, what's going to be negative, right? So, depending on where my angle is, like is my point going to be positive or negative? Because that is going to tell us what is going to be the sign of my value. And you'll kind of see as this kind of goes to where everything's going to be at. And then step number 5 is just going to be evaluate. And you could say like evaluate and simplify. I mean, I think, you don't really need to simplify. I guess it all depends on your teacher, right? But anyways, I always made my students simplify. So you should get used to simplifying. And we'll do some examples here that are going to help simplifying. So let's get into some examples following this process. All right. So the first example is going to be a sine of 4 pi over 3. Okay. So how do we evaluate the sine of 4 pi over 3 using the unit circle? So step number 1, sketch the angle. Now again, the more you do these, the better and faster you're going to get at this. 4 pi over 3 is right here. There's my 4 pi over 3. All right. So it's larger than, that's 3 pi over 3, and then your extra pi over 3. So that's step number 1. Step number 2 here. Actually, I'll go over here. Step number 2 is going to be find the reference angle. My reference angle is going to be my distance here from here to here. That's going to be my theta prime. Theta prime in this case is going to be a pi over 3. Now, what is the point on the unit circle at pi over 3? So hopefully, again, you can kind of cheat if you want to. Go back up here, right, and say, all right, pi over 3, what is that coordinate point? Oh, yeah, it's 1/2 comma square root of 3 over 2. Got it? Okay, so therefore, it's going to be a 1/2 comma a square root of 3 over 2. Step number 4 is identify the quadrant. Okay, so which quadrant are we in? We are going to be in quadrant 3. Now, why is that important? The reason why that's important is because the x and my y are both negative. Why is that important? Well, because what is sine? Now we got to evaluate. Sine represents the y coordinate, right? So what is my y coordinate? My y coordinate is square root of 3 over 2, but it's in the 4th quadrant. So it's a negative square root of 3 over 2. So my answer, the sine of 4 pi over 3 is equal to a negative square root of 3 over 2, right? So you can see I found the angle. The angle helps me identify the reference angle, which helps me identify the point And then I use that angle to help me identify the quadrant, which helps me identify the sine. And then I can go and evaluate, and I don't need to further simplify. In this case, we are all done. So that was one drawn out. And again, guys, like I did that, you might say, well, like, oh, it's much easier just to memorize the unit circle, right? I'm explaining this step by step, but when I have to evaluate using the unit circle, all this stuff I'll usually do in my head, right? So, and you can do that too. The thing comes down to like getting practice. The more practice you have with evaluating trigonometric functions and with the unit circle, the easier things are going to be. So let's go ahead and do some more practice. And again, like as we get through more practice, I'll just kind of speed up my explanation and hopefully you can kind of, follow along with that. If not, then pause the video, do it at your own pace and see if we get the right answer. So this next one, I have a cosine of 11 pi over 6. So first thing we're going to do is I'm going to sketch the angle, right? So cosine 11 pi over 6. Now in this case, you are going to want to know that that's in the negative direction. And that's going to go in that way. Okay, it's almost going to be 2 pi. 2 pi would be 12 pi over 6. So therefore, I sketch my angle. Step number 2 would be finding my reference angle, which you can see is going to be a pi over 6 away, right? So I can say theta prime equals a pi over 6. Step number 3 is going to be identifying the coordinate point. So pi over 6 is going to be a square root of 3 over 2, comma 1/2. What quadrant is this in? This is in the 4th quadrant. That's awesome because I just have everything's going to be positive, so I don't have to worry about negatives here. Even though the angle's negative, the value, the coordinate points is going to be positive, right? And then I'll evaluate. So cosine of an angle, remember, represents the x-coordinate. So what is my x-coordinate on my coordinate point? Square root of 3 over 2. Again, it's in the 1st quadrant, so everything's positive. So therefore, this answer, let me just write the answer. I don't need to rewrite the whole expression. So my answer in this case is going to be a square root of 3 over 2. Voila. All right, you guys ready to do another example? All right, let's go and do another example. How about the tangent of 11 pi over 4? So if I did the tangent of 11 pi over 4. Now, here's a good example of where I think things could get kind of confusing for students. And actually, let me just kind of go horizontal here. So sometimes students are like, I don't know where this angle is, right? Like, I don't know how to evaluate this. And a lot of times students, when they have like the unit circle memorized, I give them 11 pi over 4 and they like kind of freeze up. They're like, it's not on the unit circle. How do I do this? And I'm like, you got to know how to graph it. All the way around the circle is 8 pi over 4. How much more do I need to go than past a revolution? Well, 8 pi over 4 to 11 pi over 4 is just going to be an extra 3 pi over 4. Right? So now technically 11 pi over 4 is the same as have the same value as 3 pi over 4. Now, that's step number 1. Step number 2 for my students would be identifying the reference angle. If this is 3 pi over 4, then my reference angle here is just going to be a pi over 4. All right, step number 3 is identifying which quadrant we're in, which is going to be in quadrant 2. So that's a negative x, y, right? So that's in quadrant 2. And then step number 4 is going to be now evaluating this. Now, again, remember, tangent represents the y over the x, right? So tangent of theta represents the y over the x. Actually, you know what? I should maybe do that. Maybe I should just write that. Cosine of theta is equal to the x coordinate. Just do a reminder. Was that this one? Yeah, cosine of x equal there. Yeah, and sine of theta is equal to y, which is equal to a negative square root of 3 over 2. There you go. I just want to kind of represent that square root of 3 over 2, just so you can kind of remember. So tangent theta represents the y over x. Now, I kind of ran out of room, so let's go ahead and kind of rewrite it down below. Now, thankfully, this is not as bad as it kind of seems. A lot of times when students look at this coordinate point, the coordinate point 3, I did this all wrong. I missed my steps. Step number 3 is to identify the point on the unit circle. This is a 5-step method, Mr. McLogan. The point on the unit circle is going to be a square root of 2 over 2, comma, a square root of 2 over 2. Step number 4 tells you which quadrant it's in, which is in quadrant 2. So therefore, this is going to be a negative x, comma, y. All right, so step number 5 now is to evaluate. So remember, the tangent of my angle, of any angle, tangent of theta, is equal to a y over x. Okay, so when I have the tangent of 11 pi over 4, now I need to take is my x is now going to be a negative point, right? So tangent of 11 pi over 4 is going to equal here a square root of 2 over 2 divided by a negative square root of 2 over 2. But notice they're exactly the same angle, guys. Just one's positive, one negative. So therefore, that is going to equal, I didn't want that to look like that. That is now going to equal a negative 1. And actually, just realized this is mathematically incorrect, so I don't want to solve that. That's not equal. There you go. There you go. But let me rewrite this angle. So if I said the cosine of negative 11 pi over 6 is equal to square root of 3 over 2. There you go. Okay. Right? Yes. Okay. Let's go and do another one because there's still some things that students can get tripped up on. Okay. So another thing that students can get tripped on is what about if we use the reciprocal function? So in this case, what if I had the cotangent of a negative pi over 3? Okay. Now, a couple things that students need to understand is, again, like graph the angle, right? So step number 1, let's graph it. So negative pi over 3 is going to be right there, right? Step number 2, what is the reference angle? The reference angle is going to be, again, this distance here back, right? So the reference angle is just going to be pi over 3. Step number 3, find the point. So pi over 3 is going to be a 1/2 comma square root of 3 over 2. And step number 4 is we know this is in the fourth quadrant. So therefore, my coordinate point here now is a positive x and a negative y. All right. So now what we need to do is go ahead and evaluate this. So to evaluate, remember that the cotangent, cotangent of any angle is equal to my x over my y. Now notice in this example though, my y is negative, right? Because this point is in the fourth quadrant. So what I have here is I have the cotangent of negative pi over 3 is equal to a x, which is my 1/2, divided by a negative square root of 3 over 2. Now in this case, my 2's can divide out, and that's just going to leave me with a 1 over a negative 1 over square root of 3, negative 1 over square root of 3, which now you can rationalize the denominator to give you a negative square root of 3 over a 3. So make sure that negative stays with you. You can multiply by the reciprocal, and that's how you can see how the 2's kind of get divided out. But again, this is one of those tricky simplifying problems, right? Technically, once you place it in there, you've evaluated it, so you're good to go. But yeah, then again, sometimes it can get tricky with students pulling up from on there. All right, let's go and do another example. What about cosine of 3 pi over 2? Because now I want to kind of get into examples of like, what if this doesn't have a reference angle, right? And if you look at this example here, if you go ahead and sketch this, 3 pi over 2 is all the way over here. It doesn't have a reference angle. So if it doesn't have a reference angle, how can we understand this point? And this actually kind of comes into a little bit different where we can't really use our 4-step method because if we don't have a reference angle, it's not in a quadrant, right? It's on the y-axis. So how can we understand what's going on here? And to do that, what I want to do is kind of go back to our original problem. Remember these points here, right? 0, 1, 1, 0. So in my example, this most recent example that I have, this point, this 3 pi over 2, right, angle goes right here. So that's going to be 0, negative 1. And we should also know this point too, right? Just a negative 1, 0. Okay, so if it doesn't have an acute angle or a reference angle, it doesn't have a quadrant, we need to understand what that point is on the unit circle. So when I go ahead and sketch this graph, I recognize that this is at a point of 0, negative 1. Now remember cosine, right, represents the x-coordinate. So what is the x-coordinate here? 0. So my answer is just 0. Let's do one more example here. What about if I had the cosecant of, let's do 3 pi. All right, now remember cosecant represents, so cosecant of any angle equals 1 over y. Again, first thing you're going to want to do is sketch the angle, okay? So what we have here, let's do negative 3. Negative 3y. Negative 3 pi. So we're going to go in the negative direction. Okay, so negative direction. There's negative 2 pi, and then we'll do an actual negative 3 pi, which will take us right here. And again, what is this point on the unit circle, right? We just looked at it over there. If you were to take this on the unit circle, right, this point would be a -1, 0. Now, again, remember cosecant represents 1 over y. So the cosecant of -3 pi is going to equal a 1 over 0. Well, can we divide by 0? No. So this is an example of an undefined value. So hopefully, ladies and gentlemen, you understand now what are the things you need to know to evaluate on the unit circle. And this video and my 5 steps formula was helpful. So if therefore you can evaluate any trigonometric function using the unit circle. And if it was, I look forward to seeing you in the next video. Cheers.